Welcome to this presentation and live coding session about using BRF Plus to implement a document constraint check in i.s.h.med. This video is part of an SAP Community Network blog. If you are viewing this on YouTube, you can find the link to the article in the description. In the article, I provide some background information about the problem to be solved, and I outline why you should consider using BRF Plus for this job. I won't repeat this discussion in the video, but rather show you how the solution is actually built. To summarize the task ahead, we want to prevent the creation of patient-level documents by making sure that every document has a case ID assigned, but with some exceptions. In this case, we've got two institutions to take care of. In institution 7, there are two document categories that should be allowed to be created on a patient level unconditionally. And in institution 1, the situation is slightly more complex. There are 5 document categories that are allowed to be created on a patient level unconditionally. There are 2 document categories that may be created for some documenting OUs that are shown here. And there are 2 additional document categories that may be created on a patient level for another documenting organizational unit. In order to integrate our check into the standard processing, we need to find an appropriate extension point. In this case, it's an enhancement spot called i.s.h.med doc create. The enhancement spot is flagged for multiple use, which means that we can simply add a new implementation to the existing ones. Of the 4 methods provided by the interface, check.admin data is the one we need to implement. The signature of the method tells us that we will get the admin data to check in a structure named rn2 doc.admin create. Although we don't intend to change the doc.admin data, other implementations may have done so, so we need to observe this additional parameter as well. We will have to feed the results of our checks into this error handler and set the return code appropriately. Knowing that this structure is the only source of information for our checks, we can now start the BRF Plus workbench. On the left-hand side of the screen are a number of applications I already created earlier. They are of no importance to us. We simply create a new application. We'll enter a name and description and make sure the storage type is set to customizing. This is important for the transport logic. We also need to specify a development package and a software component. Now we save the application and add it to a transport request. There are lots of places to leave documentation in BRF Plus. For instance, we may want to use the general information of the application to leave some text describing our application. I'll now add the application to my personal favorites and switch the view on the left-hand side so that we can focus on that application only. Now we need to create a function, which is an entry point that will be called from the ABAP implementation later on. Again, we add a name and a description and navigate to the newly created function. We could again leave some documentation here, but I think you get the idea. Let's move on. On the Signature tab, we specify the so-called context, which in this case only consists of the input data of the function. Since the application is still completely empty, we need to create a new data object and add it to the application. We select a structure and enter the name of the data dictionary structure that we found out earlier. The system will preset the name and text from the dictionary information, so we just have to copy in the short text. There is no point in navigating to the structure, so we just create it. By default, the function is set to event mode, which is what we want. We want to process actions that generate messages. We now activate the function and in the process activated all referenced objects as well. That's the structure and all of the elements created with the wizard. In the repository on the left-hand side, we can now see that both the application and the function are active. We could also examine the data objects created earlier, but we'll skip that for now. You will have observed that the application does not contain any business rules so far. This is intentional. I'd like to demonstrate that it's possible to change the business rules later on without having to adapt the ABAP coding again. To proceed with the implementation, we use this button to generate a code template. This may look like a lot of code, but it's heavily commented. You can turn off the generation of comments if you should wish to do so. This is the point where we'll need to pass our input data later on. For now, we'll re-enable the comments and copy the generated code to the clipboard. Back in the ABAP world, we create a new enhancement implementation, a new body implementation, and an implementation class. To keep things nice and clean, we'll just wrap the generated code in a separate method. Now we paste in the code from the clipboard. Instead of the generated local variable, we'll use an importing parameter. BRF Plus will pre-generate a catch clause, but we want to handle the exception in another place, so we'll just remove this and add the exception to the signature of the method. With the wrapper method in place, we can now move on to the actual body method. We first have to account for the fact that some other implementation may already have changed the admin data. If something goes wrong, we can use the error handler to present the error message to the user. As I've already said, we will use actions to generate messages. BRF Plus will store the messages in the BAL application log, so here we'll call a small auxiliary method that will retrieve the messages from the log and store them in the error handler. This method searches the BAL global memory for logs belonging to that application. It then retrieves the messages from the memory and adds them to the error handler one by one. If it encounters an error message, it will set a flag that we can evaluate later on. Finally, it removes the messages from the log. As you can see, this method does not contain any business logic at all. It is completely generic and can be used wherever necessary. Back in the implementation class, we use the flag exported from the method to set the return code accordingly. After activating all the objects, we can return to the BRF Plus workbench to implement the actual business logic. The rules will be implemented in so-called rule sets. We will create 2 rule sets, one for each of our 2 institutions. For larger installations, it might be a good idea to place the different rule sets in different applications so that they can be edited and transported separately. For our installation, that won't be necessary. Rule sets are maintained on the Assigned Rule Sets tab of a function. After switching to edit mode, we can now create a new rule set. After entering a name and a description, we navigate to the newly created rule set. In the rule set header, we specify a precondition to ensure that this rule set is only applied for institution 1. Since we created the rule set from the function, it has inherited its context. That means that we can simply select the institution from the parameters and specify a value here. We now save the rule set, return to the function, and then create the second rule set in the same way. As you can see, both rule sets are now assigned to the function, while the preconditions ensure that only one rule set is ever processed at a time. We will implement the rule set for institution 7 first because it's much less complex. We create a new rule and specify a description. The rule is supposed to be triggered when no case is assigned to document. We can use the condition editors to specify just that. To check the document categories, we need a nested condition, and we use a separate rule that we create from here to implement that. Again, this new rule inherits the context of the rule it was created from, so it's easy to specify a condition for the document category. Note that it's easily possible to specify alternative conditions as shown here. Now we need to specify what should happen if the condition is met, or in this case, if it is not met. We create a new action that will log a message. For this action, we can keep the default settings. Note it's important that this flag persist is not set because we want to be able to retrieve the messages from the application log from memory later on. We now specify the message text and change the message type to error. Then we save the action and return to the rule. In its current form, the rule is relatively easy to read. If the document category equals one of the two specified here, then nothing happens, otherwise an error message is logged. Now let's activate everything we have created so far and return to the function to implement the second rule set. Again, we specify a top-level rule that will check whether the case ID is specified. And just as before, we use a secondary rule to specify whether it should be allowed to create the document without a case assigned. Since the error message is the same, we can reuse the action we created earlier. You will remember that the conditions for institution 1 were considerably more complex, so we'll have to use a more powerful tool to implement them as well. In this case, we will use a search tree. It's worth pointing out that the same result can also be achieved with other expression types. From the rule, we create a new expression, select the search tree as type, and enter a name and possibly a description as usual. We want this expression to return true if document creation is allowed, false if it isn't, so we select a Boolean return value. This search tree operates in qualified match mode. This means that the system will try to evaluate the conditions specified here to descend down the levels of the tree, and the last condition that was met on the way down determines the result value. Since we want to allow the creation of patient-level documents for certain special cases only, we set the top-level result to false. Now we add a condition node to the tree and specify the first set of document categories for which we want to make an exception. We can now specify a set of document categories, just like we did before. For these document categories, there are no further checks to be made, so we just specify true as a result. Now we create another condition node on the same level for the second set of document categories. For these document categories, the default behavior should be to reject patient-level documents, so we set the result to false. However, we want to make an exception for certain documenting OUs, so we add a condition node below the current one to specify this. For these exceptional OUs, we set the result value to true. We can now add the last branch of the tree in the same way. Again, creating these documents on a patient level should generally not be allowed. We now add another condition node to specify the one exception. Now we can save and activate the search tree and try it out using the simulation mode. We'll skip the entry screen for a moment. On this screen, you see the elements of the context that are actually used in the search tree. You can specify some values here and run the simulation. Since this combination was not on any of the exclusion lists, the search tree returns false as expected. You can also run the simulation and display the processing steps involved in getting to this result. This can be very helpful when debugging complex rule sets. When we rerun the simulation with some values that are on the exclusion list, we get true as a result. Back in the workbench, we need to make sure that we activate every object we created. Now we can try it out from the application. Unfortunately, I have to log on in German to do so, but I think you'll get the idea. I have requested 2 services for this patient, one without a case ID assigned, one with. We'll create a document with a case ID assigned first, and as expected, that just works. However, the organizational unit we used was on the exception list, so just to be sure, we'll check with a different OU. Again, it's possible to create this document. Now we try the same thing for the service that does not have a case ID assigned. Since the document category and the OU are on the exception list, it's possible to create this document as well. If we try to use a different documenting OU, however, we get an error message. That concludes this video. Thank you for your interest. If you have questions or comments, please feel free to leave them either in the SCN blog or the YouTube video. Thank you for watching and have a nice day.